Okay, so this time the second derivative test. By the name suggests, we will be using the second derivative. Okay, but let's provide again a visual interpretation of the second derivative. So the second derivative test is also used to find the maximum and volume, maximum or minimum. And it will start by identifying the critical values x and eventually be testing this x whether they will give us a maximum or minimum. Okay, so some things to note. We will start with the derivative and then this will be followed by the second derivative. Okay, so how do we apply the second derivative in identifying whether a given critical value will give us the maximum or minimum? Okay, so this is the process. So step number 1, you still have to find the derivative and the values that will make the derivative equal to 0. Okay, suppose a c or an x equals c is the number that can make the derivative equal to 0, then we will be testing that number using the second derivative. Okay, so step number 2, find the second derivative of x. Okay, and then you make a certain interpretation. There are 3 things that can happen. At f double prime of c, so remember the c is the number that we obtain from the first derivative. So we will be testing the f or the second derivative at x equals c. There are 3 things that can happen. Maybe it will be 0, maybe it is greater than 0, or maybe it is less than 0. And their interpretations are, if the second derivative at c is greater than 0, then the c will give us the minimum value. So minimum value at c. If the second derivative at c is equal to 0, there is no conclusion that can be made. It means the second derivative is not the best way to test for the maximum or minimum. Then that means you have to go back to the first derivative. If it is less than 0, then the maximum value can be obtained at the value of c. Okay? Let's go back to our previous example so that we can connect the ideas. Okay, the volume of x, the volume x function, which was 4x cubed minus 120x squared and then plus 900x. Following the steps, we need to find the first derivative, in this case v prime of x, and we set that to 0. And we found that the derivative will be 0 at x equals, in our previous example, x equals 5. So this is our c. So instead of testing the 5 using the first derivative test, we proceed directly to the second derivative. So we have to compute the v double prime of x. And the v double prime of x is 12x squared. The v prime. Wait, the v prime is 12x squared minus 120x plus 900x, right? So 12x squared, 120x plus 900. So that means the second derivative is, so coming from this, it will be 24x minus 100. Did I miss anything? It should be just 900, right? So we have 120, x becomes 120, 900 is 0. That is a second derivative. then you will be applying this concept. You have to test if you substitute the c in the second derivative, will it give you a greater than 0 number, an equal to 0, or a less than 0 number, meaning positive, 0, or negative. So we will be testing the 5 on the second derivative. So v double prime of 5 means 24 times 5 and then minus 120. What is this equal to? So this is equal to 120 minus 120. So it's equal to 0. So v double prime of 5 is equal to 0. Unfortunately, in our rule, if it is equal to 0, then no conclusion can be made. So in this specific example, the second derivative test will fail. Hence, we have to resort to the first derivative, which we have already shown in the other discussion. Okay, so let's, I think the box question is not best for this second derivative test example. Let's have a different one. Okay. Let's try it on a general function. What I want you to do is consider the function f of x to the 4 minus 8x squared, and we apply the second derivative test. We just call it s dt, second derivative test. Okay, so I'll give you some time, work on the first derivative, find the critical values, and then we proceed to the second derivative. Okay, so do it now. So let's solve this. So for the second derivative test, we still need the first derivative, and the first derivative is 4x cubed minus 16x. The critical values will come from f prime of x equal to 0. Meaning to say, 4x cubed minus 16x is equal to 0. So we have to solve this. Factor out x, 4x rather. X squared minus 4 equal to 0, which is also equal to 4x. X minus 2 and x plus 2 equal to 0. So 4x can be 0, x minus 2 can be 0, or x plus 2 can be 0. So x is either 0, x is equal to 2, or x is equal to negative 2. So note that this example is not an application question. So there is no restriction for x to be, is it just positive numbers? This one has no restriction. X can be a positive number, it could be 0, it could be a negative number. So all these values are what we call the critical values. So these are your CV or critical values. Okay, so instead of testing them using the first derivative test, we apply the second derivative test. So that means we have to go and find the second derivative. So 4x cubed minus 16x is the first derivative. So 4x cubed minus 16x. So the second derivative is equal to 12x squared minus 16. Okay. Then, noting those numbers, so negative 2, x is equal to 0, and x is equal to 2, we have to test them using the second derivative expression. What will be the second derivative if x is equal to negative 2? So that means 12 times negative 2 squared minus 16, and this is equal to, what is this equal to? 12 times 4. 48 minus 16 is 32, and this is a positive number. And whenever the second derivative is a positive number, it means you will get a minimum, specifically a relative minimum, because we're not yet sure whether this will be the highest or the lowest. So relative minimum at x equals -2. Okay, now when x is equal to 0, it means 12 times 0 squared minus 16. This will be equal to -16. It's a less than 0 number. That means you will get a relative maximum at x is equal to 0. And then, when x is equal to 2, actually it will be the same as the first one, right? It will be 32, this is greater than 0, and this will be, or this will give us the relative minimum at x equals +2. Okay, so if the question is like, find the relative minimum, then all you have to do is to use the x equals -2 and x equals 2 on the given function. Find the relative maximum, then use x equal to 0. Okay, so now all we have to do is to find the corresponding y. X is equal to 0 and x is equal to 2. Where are we getting the y? The original function. And the original function was the f of x, or the y, is equal to x to the 4 minus 8x squared. Okay, find the corresponding value when x is equal to -2. That is 16. Let's compute. -2 raised to 4 minus 8 times -2 squared. This will be equal to, that's 16 minus 32, right? So -16. And I think that will be the same when x is 2. It's also -16. But when x is equal to 0, that will be 0, right? Change all x by 0, then that means the y is equal to 0. So you have to be specific when it comes to finding a certain value. So if I say what is a critical point, then we have -2, -16, 0, 0, and 2, and -16. If I say what are the relative minimum, then you say the relative minimum, well, they're the same as -16, so it's just -16. What is a relative maximum? The value is equal to 0. Your answer should be specific to what is being asked. What are the critical values? -2, 0, and 2. Okay? So, are there any questions about on how we apply the second derivative test? Okay, so to summarize again, the second derivative test still involves the first derivative. That is, we need to find the first derivative to find the critical values, and then we proceed to the second derivative and test these values. Which among them will give us a maximum or minimum? Okay.